This is a result of a number of ecological events that all came together into one very unique landscape. Over the history of the Earth, eastern Washington has gone from oceanfront property to covered in volcanic rock to a glacier. These events all coming together, giving us the Palouse as it is today. Batholiths are large underground deposits of igneous rock. They form what are called laccoliths when magma rises into Earth's crust without breaking the surface. The magma then cools, forming large rock structures. Batholiths and laccoliths are what caused the formation of Moscow Mountain near Kamiak Butte. The cooling of underground magma rose the Earth's crust, creating a large rock formation known as Moscow Mountain. The flood basalts are a type of dark rock formation. They are the result of a lava flow or series of lava flows over a large area of land or underwater. About 15 million years ago, lava flowed over the Palouse, covering every inch of land except for the taller points such as Kamiak and Steptoe Buttes. These lava flows left behind flood basalts across the land. These formations are still found in the Palouse and across much of Washington state, including the Columbia River. Following the flood basalts came the Ice Age. An important factor on the Palouse during this time is glaciation. Glaciation is the process or result of land being covered by glaciers, as the Palouse was during the Ice Age. However, around 11,000 years ago, glaciation began to slow, and the glaciers were melting. The giant ice sheet covering northern Washington into Canada was melting, um, gathered behind a small ice dam that was near to giving in to the water pressure. When the dam finally did break, it released a large wave over eastern Washington. During this time, the Palouse was covered in glaciers, stretching all the way down from Canada. The combination of strong winds and the wave coming from the northeast moved silt across the land of the Palouse. This silt, ground into fine powder by the still standing glaciers, is known as loess soil and is what forms the rolling hills that we see today. Climate is a combination of a number of different factors, such as air masses, topography, continentality, and more. These things are what give every region its own unique climate, including the Palouse. Air masses are bodies of air with uniform temperature, humidity, and pressure. These factors are determined by the area of their origin and their direction and route of movement. Air masses can be major factors in a region's weather and climate. The Palouse experiences a marine polar air mass coming from the west. This air mass tends to be cool and moist and modified by the ocean surface as it travels across. This modification also affects the land, which is the reason for Washington state being considered partly marine and mostly marine modified macroclimates. A macroclimate is exactly what it might sound like, the overall climate of a large scale of land. In Dr. Schlosser's lecture on climate at Washington State University, he explained that macroclimates are a function of origin of air mass, latitude, continentality, and topography. This means that the microclimate can be defined by the air mass that moves over it, the location in relation to the equator, the distance it is from the ocean, and the configuration of land surfaces. Crossing western to eastern Washington State also means crossing from a marine macroclimate to a marine modified continental macroclimate. This is because of the continentality increasing as you move further away from the Pacific. The land is still affected by the ocean because of the marine polar air mass moving over it. However, it is not close enough to the ocean to be considered a marine macroclimate. One of the most important topographical features of Washington state is the Cascade Mountains. These are represented in this figure on the slide, where it shows the topography of Washington state and the rain clouds as they pass over. This mountain range has a huge part in the climate and the weather across the state. As objects increase in elevation, they tend to cool because of the thinner atmosphere. This is the case with the clouds as they pass over the Cascades. The clouds increase in elevation and cool. This cooling causes condensation and precipitation. We know that the clouds are moving west to east because of the air mass moving in that direction. As the clouds begin to descend towards eastern Washington, they begin to warm again. The warming increases the cloud's carrying capacity of water as vapor, meaning that it can carry more without dropping it in the form of rain, snow, or hail. This is evident between points C and E, which receive less precipitation than points A through C. However, the precipitation does have to fall somewhere. Following the path of the clouds, they continue to increase in altitude because of the increasing land elevation into northern Idaho. Once again, the clouds become cooler and higher up as they go, decreasing the carrying capacity and causing the precipitation to finally fall around point E. The topography in relation to Washington state, and specifically the Cascades, is the reason for such high precipitation in western Washington and into northern Idaho, and yet much lower rates in eastern Washington and the Palouse. This figure shows the annual precipitation in Kamiak Butte. The overall climate of Kamiak Butte is the result of a combination of the air mass topography, continentality, and latitude. Taking all of these factors into account can give reason to the climate of Kamiak Butte. Kamiak Butte is situated in a marine-modified continental microclimate on the east side of the Cascades, about 350 miles from the Pacific Ocean. The chart on this slide represents the annual rainfall and temperatures each month from those years, between January 1895 and December of 2021. We can see that the highest precipitation occurs in the months of November, December, and January. These months also hold the lowest temperatures for the region. In contrast, the months of July, August, and September have the highest temperatures and lowest precipitation. This is because of the macroclimate being marine modified continental. While researching Kamiak Butte, the class visited multiple locations. These are small locations within a region that can be used to study things such as an ecosystem or biotic life. Kamiak Butte has two distinct faces, the north and south facing aspects. The north side has significantly greener vegetation due to the amount of shade it receives. On the north facing aspect of Kamiak Butte, the tree species are thriving and the plant life in general is abundant. The figure on this slide shows the data from the first site on the north facing aspect. It shows the number and type of species, heights, diameter at breast height, and dominant species. The main tree species in this region are Douglas fir and western larch, with a few ponderosa pine. We can see that the trees on this part are dense with the dominance of Douglas fir. This part of the park has a number of lichen and grasses that are important to note. The forest floor is covered in different plant species. One very important one is ghost pipe. This plant works as a very important bioindicator species. As a non-photosynthetic plant, it relies on nearby species for all of its energy and therefore can only exist in very healthy ecosystems. This area also has an abundance of lichens that latch onto the bark of trees. The fungi provides a safe sheltered habitat while the cyanobacteria provide food for the fungi. This region has minor evidence of disturbances that have an effect on the ecosystem. One of these is the proof of a bark beetle attacking the tree where it has lost all of its bark. The bark beetle killed the tree a while ago, and the woodpeckers began breaking the bark off to reach the beetle larvae and eat them. This is important because it protected the surrounding trees from that same beetle. The south-facing aspect of the butte receives significantly more sun than the north, so the vegetation is less shade-tolerant, but more fire and drought-resistant. The south-facing aspect of Kamiak Butte is much different in appearance from the north one. This figure on the slide shows the data from the site on the south-facing aspect. It shows the number and type of species, heights, diameter at breast height, and dominant species. The tree species present, however, are similar in that there is a high number of ponderosa pine. This species tends to be tolerant of drought, heat, and even wildfires. This is an important factor on this part of the butte, as fires here are much more common and the sun is not filtered as it is on the opposite side. There aren't nearly as many species of forbs and shrubs on the south-facing aspect. The main two tend to be North African grass and Idaho fescue. These two grasses cover the ground over the majority of the aspect. However, there is a higher abundance of the intrusive North African grass. This is because the grass is extremely unappetizing to the wildlife and therefore is not eaten nearly as much as the Idaho fescue. Wildfires are much more common on this part of the butte than the north-facing aspect. Because of this, ponderosa pine are the dominant overstory species due to their thick bark that leads to fire tolerance. There are lots of biotic factors that affect the environment. Some of these things are relationships between species, the types of species, and the wildlife. There's an abundance of evidence of plant-to-plant interactions on both aspects of the butte. Some previously discussed are the lichens growing on the Douglas fir, as seen in the picture on the slide, or the ghost pipe taking the energy from surrounding plants. Another very important one to discuss is the mycorrhizae interacting with the trees. The mycorrhizae live in the soil and around the tree's roots, where it cannot photosynthesize. Due to this, it takes up some of the energy that the tree makes in its leaves and in turn brings up the water and nutrients that live too far down in the soil for the tree's roots to reach. This is a mutual symbiotic relationship that benefits both parties equally. Mycorrhizae are so important because they also, in addition to this relationship, pass communications from tree to tree and even among other plants, such as grasses and shrubs, and connect the entire community of plants in the ecosystem. Kamiak Butte has lots of healthy wildlife, including moose, deer, porcupines, woodpeckers, owls, etc. These species all play a very important role in the ecosystem, keeping all species populations in check and further enriching the environment. There are both subjectively good and bad impacts from this wildlife. One good impact discussed earlier was the woodpecker, eating the bark beetles from the ponderosa pine, keeping the population of the tree happy and healthy. One example of a possibly bad impact from the wildlife would be the effect on the Saskatoon serviceberry, as seen on the slide. Since the removal of wolves from much of the United States, the ungulate populations in this region specifically have flourished and had no major predators to keep them in check. Because of this, overgrazing of the serviceberry has been a noticeable issue on Kamiak Butte, which is normally a wide flowering plant and now resembles a pile of twigs. This slide is my works cited of all the sites and sources that I used. And this is my report on Kamiak Butte.